I'd like to introduce myself. My name is Gagandeep Singh Bhatti. Most of the people call me Gagan. It's a long name. And I work for Nokia as Senior Standardization Specialist in 5G Advanced and 6G technologies. And I'm also currently serving as a Vice Chair of the Green G Working Group of the Next G Alliance, which is focused on sustainability. Uh, Before going further, I would like to ask my esteemed panelists to introduce them one by one. Mr. Alex, please go ahead.
Thanks, Gagan. Hi, everyone. My name is Alex Tu. I'm the Vice President at Qualcomm, and I'm leading currently the Chipset Power Engineering Group. So my responsibility is mainly to oversee the power consumption performance for our Qualcomm chipsets. So now we started with the mobile, and then we started to expand beyond mobile. So now we're covering compute, a laptop, automotive, IoT, XR, AR, and wearables. And Qualcomm also recently come into the base station business as well, like the chip design. So yeah, just want to make sure all our chipsets the power consumption is as low as possible to give the good performance.
Thanks,
Hi.
thanks, Alex. Please, Dr. Dinesh, go ahead.
Hi, I'm Dinesh Paradia, professor at UCSD. I generally work on everything related to wireless. So I think with that, I'm good. Please go ahead.
Sure.
Hi, I'm Shruti Bothe, and I work as a senior AI researcher in Ericsson Research's department in Santa Clara. And my background is in AI for telecommunications, and I'm also part of the Next G Alliance, contributing to Green G work package in terms of sustainability. It's a pleasure to be here. Thank you, everyone.
Thank you. Thanks to the panelists for the great introduction. I would like to start first because this panel is about the sustainability. And I would like to mention what exactly is sustainability, defining sustainability. In 1987, just after a year I born, United Nations defined sustainability as meeting the needs of present without compromising the ability of future generations to meet their own needs, which is a very powerful definition. And it shows that the choices that consumer makes are very powerful. And as per one study, younger generation they are willing to pay 10% more on the green products. And I can tell you from my personal experience, my 7-year-old, whenever he's there in the buying toys or Legos, he would like to buy the stuff where it's written made from sustainable products. And I think it's the power of education, which is causing this consumer choice changes. And I believe this is also in my son's words. He says, "Oh, let's save the planet. It's for the planet. It is for our planet Earth. That's why we want to pay 10% more. That's fine." So with that, I would like to go ahead and start the conversation. I'll join my panelists, and I have some questions that I would like to ask. And at the same time, I would also request if you have any question, please let us know. I'll give you an opportunity in between the questions as well. Thank you. Let's start the panel. So starting with, as this, I believe Shruti mentioned, we were talking offline, that in this conference, we had sustainability as a word, like 38 or 58 sometimes already.
Yeah, so sustainability, climate, energy efficiency, and efficiency in general was mentioned about 48 times, which is still second to AI/ML, of course, but then the third was data. So yeah.
It means it's important, right? I mean, at least we are talking about it. So I would like to start with a question. What are the current environmental sustainable trends in existing network and devices? And what are your thoughts on that? We'll be starting with Alex.
Yeah, obviously sustainability means a lot of things, but I want to maybe just focus on maybe from the energy consumption perspective. And you can see that, with the devices enabled by the connectivity, we have a wide range of different devices with the connectivity capability, right? So we talk about things like, IoT devices like a parking meter, use to transmit data back to the server, right? And then your watch, for example. So these are consuming about on the order of microwatts per se, right? Then you have your cell phone, which is now these days it can go up to about 4 or 5 watts sustainable power. And then you move to the next category of say your laptop and even like an automotive, we're talking about 10 to 100 watts kind of range. And then you go to another order of magnitude. We're talking about base station. I think in the previous panelist discussion, base station easily transmit over kilowatts. So if from microwatts all the way to kilowatts, tremendous range, different power magnitude, different kind of devices. And then how do you make sure that all these devices are as energy efficient as possible? That's the first thing. The second thing is if we focus on cellular connectivity, right? So everybody experienced from this transition from 4G to 5G. I still remember 2011 when Verizon launched the first 4G phone, Thunderbolt. I was one of the first users. And they're very excited to get a 4G phone. But then within a day or two, I realized, oh gosh, I gotta disable 4G because the battery drain was so bad. Right, and I only turn it on when I want to showcase to my friends, hey, see how the blasting fast speed. But after that, okay, done with the demo, turn it off. And also you buy this extended battery pack, right, for those of you who remember. But again, though, very quickly after that, all this industry is working collectively, the power consumption continues to improve very dramatically. Now, fast forward to 2019, the first 5G phone shows up in the market. Guess what? We're facing the same power challenges, right? And I still remember at the beginning, not all the great power features have been enabled in the network. I think the basic things today we see so basic connected standby CDRX was not even enabled. So 5G consumes a lot of power. But the great thing is that industry always a respond, right? So in a way, like total energy trend I see is more like zigzag. Every time you start with a new G, you focus on so much on the functionality performance, the power is so high that you work your way down. And another G comes up, you're going to go up power and it goes down. So hopefully, we're talking about 6G in the future. Hopefully, we can minimize that spike of a power in the future.
That is powerful. Thanks, Alex, for sharing that. Operators are paying billions of dollars of electricity bills per year. And I would like to ask Dinesh's viewpoints and then Shruti next on that.
So I think broadly, just to state the extent of the problem, right? So if you look at today's carbon footprint created by the broad ICT technology, right? It sort of surpasses or is at par today with the aviation industry, which essentially transports people, right? We're just transporting bits, these digital data, and then we are as worse as transporting people, right? I think, and so this has to resonate. I think there is a merit to be met, right? So one is saving the climate for sustainability. That's one sort of challenge you see on this end. But the second side, if you look at it, right, the trends of the apps and the AI and everything else coming around, right? The more people want to do with their devices, right? And even in that trend, right, at least as we are concerned for our connectivity and communication, it also is incentivizing us to make the energy or the power consumption to transport data much lower as well, right? Because the better we build this energy-wise or energy-efficient transport of data, the more people will start using the networks and push their data into the local edges, far data centers, right? And then into data centers and so on and so forth, right? But this overall ecosystem, right, of pushing data up, right, allows us to not have billions of devices, eats up lots of energy, right? And then are distributed, the wastage of those devices becomes a big problem as well, right? And so on and so forth, right? So overall, we are incentivized from both sides. One, from the climate, and two, from the apps using more and more data. That way, the overall our jobs basically become better and better, and we keep employed for longer time, right? Okay, but that sort of also goes hand in hand, right? But this is like a two-sided. Both sides are like really okay. All right, we got to get to the energy efficiency better at this, right? At that, I will pause and let Shruti add to this.
Thanks, Dinesh. Shruti, please.
I didn't know the audience was a Jurassic Park fan, but I will also give a reference to it. Earlier, Professor Gabriel mentioned about how hardware engineers are T-Rexes. I would encourage everybody to be, I've written it down so I don't pronounce it wrong, it's Aloruses. So these are far bigger and more powerful than T-Rexes. And we all have to be that for sustainable in terms of telecom networks or sustainability in general. And it's not a buzzword anymore. I feel like sustainability has to be there in terms of every technological innovation that we think about. And there needs to be this holistic approach in where we are designing and implementing these solutions. And it's not just about, say, compute efficiency or energy efficiency aspect of it. You have to look at the end-to-end chain of it, right from how you're sourcing your materials, the way you're producing it, what kind of materials you're using, the production, usage, and also what you're doing at the end of the life cycle of the product. So we talk about 6G or like the next generation of wireless communications and say that we want to keep the standard up high and, say developing newer use cases like XR. And I feel like sustainability has to be at that par as well when we think of next generation communication. So yeah.
Thanks, Shruti. Excellent analogy. I would like to go ahead with my next question. What are the challenges and lesson learned from existing wireless technologies in terms of networks and devices? What are your viewpoints on that, starting with Alex?
Okay. Yeah. Thanks, Gagan. I can probably speak based on my personal experience. The challenge is, on the one hand, maybe I'll just touch a little bit on the base station side. You see the evolution of 4G to 5G, and then, in a standard body, right? So there are a lot of things that's been defined therein, right? Regarding power saving opportunities. That's all good. We studied that very closely. But what happened is that not all the great features been implemented today. And so that's a little bit challenging because we try to work with the infra vendors and operators to see, hey, these are the greatest saving opportunities. Why can't you implement it? I want to make sure that on our device side also, we are ready. It just unfortunately, due to various reasons, schedules, cost, and whatnot, today, even if you look at release 16, 17, 18, there's still quite a few power saving features that are not able to be enabled. Obviously, it depends on region to region. So I think, maybe one thing moving forward, if we move to the 6G, making sure that, we can kind of have a better coordinations, like what are things that maybe right from the get-go, try to enable them as much as possible. So that's one example. The other example is on the device side, the challenge would be like the performance requirement keeps going up year over year, right? Higher throughput, more powerful processors, and then you need more speed, less latency, all these things. That drives the devices to be more and more performance driven, right? And the power in the sense, we're going through some challenges. So in my views, really, the lessons learned really is that we need a entire ecosystem, because power is not about individual devices, right? Power works in a whole system. So if I use the handset example, to really improve the energy efficiency, sure, you wanted the chipset vendors like Qualcomm and other vendors, to design a more efficient hardware, right, in power consumption, maybe with some kind of smart system algorithm and a software implementation. That's absolutely true. But that's not it, right? So in the entire ecosystem, you can think about also, we say the operating system plays an important role, right? Whether it's in the handset side, whether it's Android OS or iOS, you gotta make sure that your OS is structured such that it can provide some flexibilities for the app vendors or for the OEMs to be able to utilize the capability of the hardware. And also the other thing is that obviously OEMs, right? If you look at the handset, whether it's iPhone, Galaxy phone, or whatnot, they want to differentiate their products. So they actually introduce a lot of new features. Got to make sure that when you introduce new features, it's not a cost or power consumption. Then lastly, the app developer also comes into play, right? These days, in AI apps, maybe like often the developers of these applications, they are probably college students, right? All they want to know is that I got a quick toolkit. I just write my code in that. Here's my application. Maybe they are not so much aware of the energy efficiency implication of that. So this is where the app vendors, the developers, that comes into play, right? So the OS owners, and they will try to help them. Hey, you don't have to know the underneath what kind of silicons you're using to run your application, but as long as there's some kind of interface or APIs that's available to help you utilize the more efficient processor underneath, so that you can actually consume the power on your application. So yeah, to me, it's like these are 4 different pillars as an example. Like it's an entire ecosystem. They all need to be aware and work and collaborate together to drive the energy efficiency to be better and better.
That's great. Yeah, I totally agree. We are all data hungry, and at the same time, we have to save energy. It's a challenge. And Professor Dinesh, what are your views on that?
So I think few years ago, I think we sort of started looking at this, and we wrote actually a very interesting paper. But the first thing I want to maybe summarize, we found that within the ICT, again, going back to the original point I made, 70% of the energy is used by the last mile connectivity, which is the base station and the user device equipment in the world of cellular, right? Again, I want to just comment on cellular because there the data was available. It's hard to get data and comment on Wi-Fi and other aspects, right? So now let's look at the 70%, right? And so to reduce this 70% down to a very small amount of energy, we explored lots of other possibilities, right? And so before I preface my answer, I want to say I'm an avid massive MIMO researcher, right, as well. I love it, right? Okay. So the summary and the conclusion we came to is following, right? First, we got to have base stations which have shorter range, okay, not longer range, right? This is contrary to most believers of the long range, right? Okay. The shorter range, more denser deployments, right? And if they are shorter range, you don't need to use lots of MIMO/massive MIMO, right? And the problem with the massive MIMO is that each antenna you add, it doesn't equals to the amount of throughput it adds equivalently, right? It's like you have to add 10 antenna before you get twice the throughput, right? So it's really, really energy hogging in this regards, right? So now, once you start doing this densification, there are thousands of interesting questions which are associated with those, which sort of inspires and sort of have to be solved, right? Now, let me tell you what is an exciting outcome of densifying. We actually did this densification and deployed and did some studies. What we also found is that the good thing is that because of this densification, the user's power used on its modem also dropped. So in our study, we found that 50% of the power is eaten by today's phone by the modem. And then this may be on a very, very specific phone, a slightly older generation. Maybe these numbers have improved significantly. But the point I want to make is that 50% dropped to 10%, right, when we densified this, right? And this shows now user and the app developer and even the app stores are incentivized to move data to nearby far edge cloud, right? Instead of having that data being processed on the edge itself, right? And that way you can have longer battery life, longer everything, right? You just have to take data, it makes it dumb, it goes to the local device, edge device, right? Does the computing and sends the results back. So overall, the ecosystem and the user will be happy, right? And maybe the AT&T, Verizon may not be happy with this, right? But at least, I guess maybe I'm saying a slightly contrary view that no massive MIMO, right? Just have MIMO densely deployed and figure out how to coordinate them and schedule them better, right? Okay.
Interesting.
Yeah. So with that, I will maybe rest and maybe enough contradictions for today. Please go ahead.
So I have a different outlook to this. So in the telecom industry, everybody has set their sustainability goals, but nobody has defined KPIs. So how can you implement something that you cannot measure? And that is something that's required in terms of, say, standardized approach. there's no KPIs that say that, okay, if you are implementing something that you claim to be sustainable is actually sustainable. So that's the foremost thing that needs to be done. And sustainability can be, measured in different ways. First could be you track how green your systems are in terms of carbon emissions. And that's not standardized as well. So we refer to them as Scope 3 emissions. And you don't see a uniformity in how these are reported. So that's one of the major challenges. So that needs to be fixed. And of course, I mean, when you look at climate as a whole, a recent study reported that weather-related damages cost the US about $92 billion. That's a huge number. And if you look at it, it's going to get monumental after this because we have only until 2030 where we can start making a difference at the earliest.
Excellent point.
So this is there. And there was also a really interesting report that I read just yesterday. It was from Boston Consulting Group. And then everybody talks about, if we go sustainable, it's going to be expensive. Like Gagandeep, you mentioned about your child going for sustainable products, but of course they come at a price. But the younger generation, this is reported by the study that I read, was they're willing to pay the 10% premium on these green services. So if you find such reports coming out, I think it's time for us to make that change. So,
I think that's an excellent point. I would like to go to the audience and ask for a poll. Are you willing to pay 10% more for green products? So we have our answer, and also I would like to open before going to the next question to the audience. Can you please? Is there any question? Yeah, please go ahead.
Yeah, I guess Dinesh touched upon the pain point of the cellular industry on densification, and so maybe I don't know, in your analysis, did you also capture the energy cost to connect to these small cells, to this the backhaul? Is the backhaul still massive MIMO? Then it defeats the purpose.
No, I think backhaul, I think you can go to some millimeter wave where still technically not massive MIMO, but extremely energy efficient in retrospect.
Right. So what I'm saying, just expanding on it, densification has a lot of cost implications. If you dig up trenches, sustainability issues. Right. And what I was thinking is the opposite of densification, sparsification. So how do you do it? Is right now I think we have 3 national operators covering the whole country, right? So every spot you have 3 signals. It's like you have a highway that have 3 parallel highways when you want to connect anywhere. So what about sharing? So I think that's actually sparsify the network. So can you actually use through sharing, save energy, your infrastructure, everything gets reduced. But each one of them will be, of course, more advanced, bigger, beefier, because you need to have a higher bandwidth. But I don't think it's a linear increase. The increase is probably incremental when you make this shared network.
Yesterday, I think we had a lunch conversation and we put some of the operators on spot as well, right? Okay. Right. And so one specific topic is RAN sharing, right? So let me elaborate on the answer I gave earlier, right? So yes, we should definitely be doing RAN sharing, number one, right? But RAN sharing still basically one of the base stations, if you look at one Huawei base station which does 3G, 4G, 5G for all bands, it's sort of rated to be consuming 20 kilowatt, right? It's like running 4 Teslas, right? Simultaneously, right? That's what it is, right? And in any case, so going back to the point of the backhaul issue, right? So what we also did in this study is that we took into account, if I take backhaul and conduct backhaul using millimeter wave, right? And calculated energy per bit for that, and sort of having existing fiber locations, spreading the fiber out with the backhaul of millimeter wave, and the front haul or the access side still remains to sub-6 with small number of MIMO or few 1, 2, 3, 4 antennas, right? And we have enough details on what is the right way to do it. And let me make a fundamental point, and then hopefully that connects better with what I'm saying, right? So fundamentally what happens is that when I'm really transmitting at much higher power, my power amplifier becomes much lower efficiency. That's number one problem. Second problem, that large power is fundamentally wasted in the environment, right? Before it reaches the user device, right? Majority of the power goes in overcoming the path loss, right? And this is where you are creating heat in that environment as well, right? And therefore, you sort of get to a point where you're just essentially trying to overcome this physics-based hurdle for no good reason, as to like a simple way of doing this is densification, right? So better do the densification than sort of trying to overcome the physics, and sort of perhaps what I'm saying in a restated manner is that use multiple frequencies, one which is better for backhaul, one which is better for access, right? And overall, if you look at this ecosystem, right, it does the energy efficiency compared to having one large base station, right? It has to go through buildings, somehow penetrate through the buildings and go inside and still provide connectivity. These types of issues, sort of always you are spending lots of energy in the environment instead of actually directly communicating with the user. So that's the fundamental reasoning of where it all sprays up, right? Now, clearly we should be doing RAN sharing, right? Just to close it off, right? Okay. Just no brainer.
Thanks, Professor. I think it's a topic for, we can have another panel to discuss that topic. I think it's really interesting. Moving forward to the next one, I believe Shruti mentioned, we talk sustainability 58 times in this conference, but still the number one is AI. We talked about AI. So my next question is to Shruti about, do the benefits of AI for sustainability exceeds the environmental impact? Because we are talking about sustainable AI and then, AI for sustainability.
That's a really good question, and there are different perspectives to it. You'll see two extreme ends where one group would completely say that AI shouldn't be using so much power as it is. It's not going to be useful. Whereas the other side of the group says that the advantages that AI offers is way more substantial than the energy that it's consuming. And with the hype around, say, large language models and the energy that they're consuming, it's come to the forefront that everybody is talking about AI along with the energy consumption that they take. So my personal view is that the benefits of AI are far more measurable and substantial than the energy consumption. And two reasons for it is that there's a lot more to be done in terms of how we're designing AI models. We see the most popular ones, say CNNs, LSTMs, and used for different use cases, but there's a large research domain still under investigated, which is about small AI models, designing these energy efficient AI models. And I feel the academia can play a large role in this. And I would give an example actually for this is recently MIT came with an AI model called as neural circuit policies. And this is inspired from a tiny worm called as C. elegans. And it exhibits a sparsity of 90% in the network itself. So if you go with the traditional AI models, it's almost impossible to get that level of sparsity. And when you compare it to how much energy it's using, you could see a stark difference in it as well. So there are opportunities for research, and we need to come up with better AI models that can outweigh the energy argument of it. So that's one thing. And the second thing is we don't necessarily have to fit AI on everything that we have. We need to find use cases where AI is actually going to be helpful and then use it on those use cases. Otherwise, it's just going to be like, you're finding the nails to hit with a hammer rather than using the hammer to hit the nail. So pretty much, I think the direction to go forward is find these smaller, sparser models that are energy efficient and find the right kind of use cases that you could use AI on.
That's very powerful.
Yeah.
Thanks.
And just to add as well, earlier there was a point mentioned about research publications and how you should go ahead and publish results that don't work. And this is exactly one of those research areas. Tell us where AI doesn't work, and then we'll focus our attention to something else.
Exactly. Alex, you would like to add the final points we have?
Yeah, we
are running out of time. Is there any question from the audience to this excellent panel? Yeah, please.
So It's Rajiv Bagrodia. You mentioned measurement, and to me, green is somewhat like organic. It's becoming a marketing term. It's becoming hard to quantify what it is that we are trying to optimize or reduce, and what is the base that we are comparing it to. For cars, over the decades, it's become easier to have that discussion. Personally, I don't have a clear sense that in this context, we know what those metrics are.
I just before answering Shruti, I would like to mention, like, I think green is a marketing term, but at the same time, 5G was also a marketing term. Yeah, Shruti, please.
I can take this one. Yeah, I agree with that. Green is
Nokia.
yeah, green is a very broad term to define something that's sustainable. And so for us, comparing what the metrics is what the current systems are right now. So the RAN consumes about 75% of energy. And if we can have newer base stations that consume less than this, then it's better. So that's our baseline. And we're coming up with these newer technologies where we're changing the material that's being used. So switching to aluminum and silicon, that's substantially reducing the power that's being used by the RAN system. What was the other point? Sorry, I forgot.
I believe it was about the metric.
Oh, the metric, yes. Like I mentioned before, there's no proper metric to quantify how much of energy efficient the system is. And this is what calls for standardization. And I think there's a lot of initial work being done at the NGA. There's a Green G working group that recently published a KPI white paper that talks about what could be the starting of how you could measure sustainable solutions.
Yeah.
So that's
exactly.
interesting.
And just adding to that, we in the Green G working group of Next G Alliance, we are also working on a new white paper on the sustainable AI, where we'll be talking about the metrics for the sustainable AI. I think that will be a great point.
Maybe I'll just add one simple thing, which I think I can think is that, so let's say I want to do task A, right? In order to do that task A, how much energy am I using, right? So for example, it could be a simple query I want to run on my ChatGPT app on my phone, right? Tell me the answer to this question, right? I guess that should be the measure of, or that should be the way to take an application and then define baseline, and then sort of, actually, by the way, on the metric side, right, there are many papers actually trying to capture. There was one which earlier, something called waste factor metric, people have come up with. There is other metric which people in energy have come up with, and a few other things going on, right? But at least from my point of view, I think I find that if somebody defines this as a way of capturing this, and then let's take into account the energy of what happens on the phone, what happens on the base station, what happens to the rest of the core network, right? What happens in the internet? And when you get these results back, like basically what is this energy for this bit communication, right? / answering my query, right? How much is that taken up, right? And that sort of, then we can define different components. I think Shruti alluded to this earlier, right? Where basically we have to look at the end-to-end ecosystem, right? And to add to this, after you are done with your phone and your base station, how do you discard them, trash them, destroy them? Everything has to be included into this analysis then to sort of then define these things, right?
Principles of circular economy, right? Yeah.
Please continue. You can add to this as well, please.
Yeah, just a quick point, actually. I mean, I think you covered it in the interdependency on how the different aspects of the telecom network are measured in terms of efficiency. So I think you can start off in one direction, saying that, okay, I changed my materials and this caused the system to be lightweight, which indirectly contributes to lessening the amount of energy that it's consuming. So there's like, I mean, if I were to look at a pie chart, it doesn't have any, say, independent elements. They're all intersecting to the center one being energy efficient, and then you have a lot of interdependent components in it. So you cannot really specify that, okay, if I were to go with a single material, this is what could be quantified.
Great.
So
Thanks a lot, Shruti.
You're correct, right?
Yep. Very, very lively discussion. Thank you for that. And I believe we are out of time.
We
are
can take
over
this
5
offline.
minutes, actually. Yeah, definitely. And I would like to thanks to my esteemed panelists, and also thanks to the wonderful audience. Very engaging conversation, and thank you so much for that.
Thank you.